Now what we're going to do is we're actually going to write out the equation of the tangent line. Not just the slope of the tangent line, but the actual equation of the tangent line, which means that they're all going to need to be in this form, y equals mx plus b. Now the m we already know. For these examples, that's what I was having you guys calculate in the last couple examples. When we found f prime of 3, and I said there was a method to my madness and a point to doing it, well, now we're doing it. So when you want to write the equation of a line, you need two things. You need a point and you need a slope. Okay, so for our first equation here, and this is a polynomial you probably recognize, we went through and we did the entire derivative. This was our derivative, and we plugged in 3 and we got 32. Okay, if we want the point, we don't need any calculus. To get the rest of the point, you just need to plug into the original function. So we're going to go right here. I'm going to draw an arrow here. And I'm going to say original function. If you want to find the point, you just have to plug 3 into here, and you can use your calculator to do it. So we can do 6 times 3 squared minus 4 times 3. Just plug in, and that will give you that the y value of the point is 42. Okay. So to get the point, you just need algebra. To get the slope comes from the tangent line. That's why we've been doing all this calculus. The slope comes from the slope of the tangent line, which is the derivative. Okay, so if you will recall, this is what happens when you plug 3, this number, into the derivative, you get 32. That's what the slope is. The slope is 32. And so that comes from the derivative. So slope comes from the derivative. The point itself just comes from the original function. And now what you have to do is you have to be able to write the equation of a line. And there's two ways to do it. And I don't know what you guys were taught in algebra. So I'm going to show you two methods. Here's method 1. For this method, you're going to use this formula. Now this is called point slope form because you plug in a point and you plug in a slope. And if you have a point and you have a slope, you can use this. But this requires that you have to know this formula, and I don't know if you guys were taught this. This is the way my brain does it. This is how I was taught. So you're going to take the x and the y from your point, and you're going to go y minus 42, that's the y value of your point, equals the slope times x minus the x value of your point. So the parts of the point go here, the slope goes right here, 32, and then you just distribute and solve for y. You distribute here, you get y minus 42 equals 32x minus, what is that, 96? And then you have to add 42 to both sides, and you're going to end up getting y equals 32x minus 54. And that is the equation of the tangent line at the point 3. That's one way to find it. And let me draw this so that you can see what it is we're actually doing. And let me change my window just a little bit. Let me go up a little bit higher here. Let me go to 50. I'll go negative 50 there. It's just a parabola. We saw this one before. Okay, so I wanted you to see this. Now, if I go over to 3 and I go up on my curve till I hit the curve, right there, we talked about before that the slope was 32. Now look what happens if I draw the tangent line I just came up with. 32x minus 54. You can tell if it's a tangent line. Look, did you see it? Now I didn't go up really, really high, but that red line coming through there, it hits at 3 and it's sloped at 32. This minus 54 is the y-intercept, and if you go down low enough, you'll see it hits the y-axis at negative 54 down there. But you can tell if your tangent line's correct, because when you draw them both, the curve and the tangent line, it should look like an actual tangent line at that particular point, okay? So that's what we're finding. That's method 1. Here's method 2. Method 2 is all you ever use is y equals mx plus b, and you plug your point in for x and y, and you plug your slope in for m, and you figure out what b is. So this is the other way that you can come up with your line. So you would go 42 equals the slope times x plus b. And then you would subtract 96, and you'll find that b is equal to negative 54. Now that's not a line. You have to go and like recreate the line yourself. Slope x b. Now some of you are probably taught that way. The point is this: I don't care how you do it. I just want you to be able to do it. So if you like method 1, do method 1. If you like method 2, do method 2. It does not matter to me as long as you can come up with the equation of the line. So just pick one and commit now to method 1 or method 2, whichever your brain likes better. So the point comes from the original function. The slope comes from the derivative. All right. Now, we then did the derivative of 6 over x. That was the rational one with all the common denominators that we had to do. And if you'll recall, this is what we got for the slope. It was negative 2/3. So we know that this is the slope that comes from the derivative. So negative 2/3, that's our slope. But the other thing we need is we need a point. The point comes from the original. If I plug 3, I don't need the calculator, do I? If I plug 3 in right here, what's 6 divided by 3? It's 2. So you just use the function itself to finish the point. Okay, and then now, method 1 or method 2, whichever one you like. I'm going to write them both out, and then you guys can just do whichever one you want and then check against what I'm writing. So when you distribute, this is going to become positive here at the end. 2/3 times 3 is 2. Use your calculator if you don't think you trust yourself. That's one way to do it. You'll notice a lot of similarities in the numbers that you get because it does lead you to the same line. So that's how you're going to get the equation of the tangent line. If I just ask for the slope of the tangent line, your answer is negative 2/3. If I ask for the full equation, then you have to go through this process. And we're going to see this process more than once throughout this course. Okay. Now let me draw this function, see if we can tell if our equation of our tangent line is correct. So let's see, it was 6 divided by x. Let's kind of go to a standard window. All right, and right here at 3, right there, that's where I'm wanting to see my tangent line come in. So my tangent line was negative 2/3 x plus 4. And bam, it hits it right there. Do you see that beautiful tangent line? It hits right at that one number, and it totally looks like a tangent line. You would know that it wasn't right, like let's say you had gotten, I don't know, 0 or something. And then you graphed it, and you're expecting a tangent line to be right there at that point, and then your tangent line ends up not even touching. Then you're like, well, something's horribly wrong. My tangent line can't possibly be correct. So you can kind of double check on the calculator to tell if you've done it right. Okay. All right. So let me talk one more time with you about interpretations of the derivative. Just one more time. It is the slope of the tangent line. That's what a derivative is. Slope of the tangent line at a point. It's also called instantaneous rate of change. If you are talking business, it is marginal cost, marginal revenue, marginal profit. Whenever you take a derivative of those functions, you get marginals. Marginals are extremely important in the business world. It's how they predict and decide on production levels and all of that. And if you want to talk physics, it's velocity. So if you take a derivative, you get velocity. If your original function is position, then the derivative is velocity. And actually, if you take a derivative again, you get acceleration. So that's how those are kind of related in physics. But we're mostly in this course going to talk about costs, revenues, and profits. So now let's do a big example with those. But I think I'm going to make that the next video.